Hello, in this video we study matrix least squares problems. But before that, let me remind you about the least square problems and how to solve them. And we will discuss what is matrix least squares problem, okay? So for the least square problem, we have system AX equal to B, and we suppose that this system does not have any solution. We need to find an X star such that AX star minus B has the minimum norm, right? And we suppose that all columns of R we suppose that all columns of A are linearly independent. That is very important because in that case, ATA is invertible. We will study the case when ATA is not invertible in the future, okay? But now we suppose that all columns of A are linearly independent. And the formula of X star is as follows. X star is equal to ATA inverse times ATB. Right? I hope that you still remember this formula. All right. Now, suppose that we have the following matrix equation. AX equal to B, right? Where AX and B are matrices. Of course, vectors are also matrices, right? But in this case, yeah, we have only one column in X and B, right? And now we have more than one column in X and B. So how to find a matrix X star such that the norm of AX minus B is minimum? That is our problem. Okay, you know, this problem is very minor, the modification of the previous one. Let me show you that. So if you write A and then X, the first column C1X in here, the second column C2X in here, and so on, CNX, right? This is equal to B. I write in the following form C1B, C2B, and so on, CNB. So there are columns of B. And suppose that, you know, X has n columns and B also has n columns. We multiply A with each column. It turns out that A C1X equal to C1B. That is just matrix multiplication. And then we have A C2X equal to C2B, right? And so on, you have A CNX equal to CNB. So basically, you have n system of linear equations. And in order to find the matrix X star, you just need to find C1X star. The second column C2X, C2 star X, and so on, Cn star X, right? By solving n least squares problems. And then from here you get matrix X star equal to just C1 star X, Cn star X. So basically, if you have a matrix least square problems, you have to solve multiple least square problems for vectors. Okay? And now let's explore this. How to find x1 star x. By the previous formula right here, I can find C1 star x is equal to A A, negative 1, AT to C1B, right? And so on, C2 star X equal to AT A to negative 1 AT C2B, and so on. We have Cn star X equal to ATA to negative 1 ATCNB. Look at this. And then when you write them together, when you set up the matrix X star, you have the following one. X star is equal to what? The first column of X star is ATA to negative 1 ATC1B. That is the first column. The second column is ATA to negative 1 ATC2B, and so on. The last column is ATA to negative 1 ATCNB. So if I write that in the matrix form, I have the following one. X star is nothing but ATA to negative 1 AT to C1B, C2B, and so on, CNB, right? But what is this? That is just matrix P. So basically I have X star is equal to ATA to negative 1 AT and B. And that is the formula of the solutions of the matrix least squares problem. Make sense? So let's compare this formula with the very first one. I'll copy it right here. X star is equal to ATA to negative 1 AT and B, right? The only difference is in the second formula right here, you have one vector, and that is column, right? Here you have one column. So now you have a matrix X. So basically you just compile all columns together. So you have a matrix multiplication right here. Instead of B small, you have B capital. Make sense? Let's consider the following example. You have A 160,272,103 and B is 13, negative 14 and 27. First, let's check that all columns of A are linearly independent, right? All columns of A are linearly independent. So the condition is equivalent to that A is invertible, because A in this case is just 3 by 3. So this is equivalent to that A is invertible, right? So you can use calculator to find the row echelon form of A, and you see that the rank of A is 3. In that situation, yes, 3 columns are linearly independent. I hope that you can check yourself, or if you want, I can do that. Okay, let's do this. So I need to check the rank of A. So I need to write 160,272,103. I need to make a row echelon form. I multiply the first row by negative 2 and add to the second. Okay, I write 1 times negative 2, add to the second. And then R1 times negative 1, add to the third. I'll do that, at the same time. So I have 160 in here, and then 0, negative 2 with 6 is negative 12, plus 7 is negative 5, and then 2 is still 2, 0 in here, negative 6 in here, and then 3 in here. And it's obvious that, these 2 rows are linearly independent, because they are not scalar multiple of each other, right? Without computing. But let's do this. 160, and then you have 0, negative 5, and 2, and then 0, 0. Basically, you multiply the second row with negative 6 over 5 and add to the third, right? So you make this 0 already. 2 times negative 6 over 5 plus 3 is equal to 12, 15. So I have 3 over 5. This is 3 over 5. So basically, the rank of this matrix is 3. Perfect. The matrix A is invertible, and then all columns of A are linearly independent. I mentioned again, in this case, we have square matrix. So that's all we have, right? But usually if you don't have a square matrix A, so you need to check that. Probably just check the rank of the matrix. If the rank of the matrix is equal to the number of columns, then all columns are linearly independent. Okay. All right. Now we know that ATA is invertible, so we can solve this problem. I have to find AT. Let's find AT. AT is what? Is 160,272,103. I just write, rows in column form and columns in row form. And then I multiply ATA. I get 121,670,023 times 160,272 and 103. That is A. Let's multiply them. Okay. We have 3 by 3 matrix. 1, 1, 2, 2. I have 6 in here, and then 1 with 6. 6 plus 14 is 20, and then 0, 4, 3 is 7. That is the first row. Let's move to the second row. 6 with the 1 is 6, 6, 20. So I have 20 in here, of course, and then I have 7 in here because the matrix is symmetric. So I'm good. The second entry right here is equal to this times this. So I have 36 plus 49, which is 85, right? I have 85 in here. And then the last one is 6014. So I have 14 in here. The last entry right here is equal to 49 is 13. So that is ATA. Okay. So once you have ATA, you can find ATA, the inverse. All right. So you can use calculator. Let me show you how to do that using some resources on the internet. Okay. So I go to internet. I find matrix inverse. Find the inverse of matrices online. Inverse matrix calculator. Matrix dimension 3 by 3. Set a matrix. Okay, our matrix is 627 in the first. 627. I have 7 right here. I have 20 right here. And then what is the next? 85, 14. 85, 14. So I have 14 in here. And then another one is 30. 13. All right. So let's calculate this. This is our inverse. Okay. 101, negative 18, negative 35. So the inverse is equal to 101, negative 85, and then let me check that, negative 35. That is the first row. The second row is negative 18, 29 over 9, 56 over 9. Negative 18. Oh my goodness. Sorry. Negative 18, 29 over 9, and 65 over 9. So since this matrix should be symmetric, I guess I have 35 in here and then 110 over 9. Okay, so I have 110 over 9. I have 65 over 9 right here, and I have negative 35 right here. So now you already have the inverse of ATA. And then once you have the inverse of ATA, you apply to this matrix ATB, right? So you still need to find ATB. So we need to do a lot of matrix multiplication in here. Let's find ATB. So what is ATB? That is 121670023, and B is, where's B? B is 1 negative 12347, 1 negative 12347. So you have 3 by 3, you have 3 by 2, you get a matrix, 3 by 2. We can do using that website, but let's do that by hand. So I have the following one: 1 to 1 with 1 negative 1 2 is just 1. 1 to 1 with 3, I have 3, and then 8, I have 18, and then 6, negative 7 is negative 1, and then 28 with 18 is 46. The last row is negative 2 with 6 is 4. 8 with 21 is 29. So that is matrix ATB. And now we just multiply these two matrices, we get the answer we need. Okay, so basically we need to multiply these two guys. We get x star. Make sense? The matrix is not good. Maybe we can use calculator. Okay, let's try to use calculator in here online. So I already have the matrix right here. I want to multiply two matrices. So the first matrix is 3 by 3. The second is 3 by 2. I will set matrix in here. And now we just copy our matrices. The first matrix is 101, negative 85, negative 35. 101, negative 35, negative 85. No, negative 85, 35, sorry. 35 in here, and negative 85 in here. In here I should have negative 85. Negative 85. And here negative 35. Alright, and then negative 18, 29 over 9, 65 over 9. (29 over 9), 65 over 9. I think I did something wrong in here. Why we have negative 18? We should, interesting. Let me check that again. Let me go back to the previous one. So here I have negative 18. Yes, you see, I have negative 18 in here, not negative 85. It should be negative 18. Okay, and the last one is, here should be 65 over 9. 65 over 9 and 110 over 9. 110 over 9. That is the matrix ATA inverse. And then the second one, we have right here 1, negative 1, 4, 1, negative 1, 4, and the second column is 18, 46, 29, 18, 26, and 29, 46. My bad. Okay, and just calculate this. Here's our answer. Negative 21, negative 25, 23 over 3, 1013, and then 20 over 3, 170 over 3. So this is how we can solve such a problem. All right. So as we have seen that actually the matrix least square problems is not really far from the normal least squares problems. As a homework, I would like to suggest you to solve the following problem. And please send it to me, by the end of this week. So we need to solve the matrix least squares problem for the following matrices. A is equal to 1, 2, negative 1, 6, 5, and 2. That is 3 by 2. And B is, let's pick 1, 0, 1, 1, 1, 0, and then negative 1, 1, and 1. That is 3 by 3. So basically you need to find matrix X. And the matrix X is of the size 2 by 3, right? Because you have A is 3 by 2. So you would need 3 by 3 in here. That means this should be 2 by 3. Make sense? And please don't forget to show that columns of A are linearly independent. And this condition is equivalent to that the rank of A is equal to the number of columns. All right, so hope that the video is clear enough. And please, when you solve such problem, you can go ahead to use online resources like the website I just showed you. But I really recommend you to show me that. Make sense? Yeah, and once if you use calculator, we will not expect to have some errors in computation. All right. Thank you for watching and see you in the next video.